Welcome to the AI for Career Success podcast by Curt Robbins, where we help you get smarter than your competition. This is episode 127.
Hello, I'm Daphne.
And I'm Fred. This time, a topic suggested by our producer, Curt Robbins, takes us right down to the bedrock of modern AI. We're talking about the silicon.
The actual chips. We're looking at this intense, multi-billion-dollar race to build the hardware that powers every single generative AI tool you use.
Right. And to guide us, we've pulled insights from the CNBC YouTube video, how Nvidia GPUs compare to Google's and Amazon's AI chips.
In this market, it's not simple. You've got GPUs, you have custom ASICs, that's application-specific integrated circuits, and then FPGAs too.
So our mission today is pretty straightforward. We're going to break down these categories for you, the professional, so you can really get the trade-offs, the speed, the cost, the efficiency.
Exactly. We want to look at the big players and figure out who's really defining that competitive edge, because the chip you're running on, that fundamentally dictates what's possible.
When we talk about AI hardware, there's really only one place to start, and that's with the king of the castle, Nvidia.
Oh, absolutely. I mean, their transformation from just a gaming company to being the absolute core of generative AI is just staggering.
I saw they briefly hit a $5 trillion valuation. That's just mind-boggling.
Well, that's what happens when you ship 6 million of your latest Blackwell GPUs in a year. I mean, their GPUs are really the general-purpose workhorse of AI.
Though we should probably mention AMD is chasing them pretty hard with their Instinct line.
They are. But the question is, why a GPU in the first place? For people used to thinking about CPUs, the central processor, it can be a bit confusing.
Right. What makes it so perfect for AI?
It all comes down to parallel processing. A GPU was built to render graphics for video games.
So calculating millions of pixels all at once.
Exactly. It needs thousands of tiny specialized cores all working in parallel. A CPU, on the other hand, it has a few really powerful cores for doing one thing at a time, sequentially.
Like running your operating system.
Precisely. And it turns out that AI training is just a massive matrix multiplication problem. It's basically the kind of math that a GPU is perfectly designed to handle in parallel.
And this wasn't obvious from the start, was it? I mean, what about that 2012 AI Big Bang moment?
That's where it all clicked. Researchers basically, they hacked an Nvidia gaming GPU using their CUDA platform. They figured out how to unlock all that parallel power for deep learning.
So they took off-the-shelf gaming hardware and solved this huge scientific problem.
And that set the stage. The GPU became the default. It's perfect for that first phase of AI computation, which is training.
The heavy lift.
The heavy lift, teaching the model from these huge data sets. But the second phase, inference, that's what affects us every day as professionals.
That's the AI making a decision, like predictive text or a chatbot answering a question.
Exactly. And as these models get more mature, the whole economic game shifts from that one-time training cost to making inference faster and cheaper.
And that's what's opening the door for NVIDIA's rivals.
That is the big opening, that chase for efficiency.
Which brings us to the biggest challenger, the custom ASIC. The application-specific integrated circuit.
And these are coming from the cloud giants themselves. Google, Amazon, Meta, Microsoft.
So what's the trade-off here? The source had a great analogy.
It did. The GPU is like a Swiss Army knife. It's flexible, it's great for all sorts of workloads, perfect for a startup.
Okay, and the ASIC?
The ASIC is a single-purpose tool, like a wrench that only fits one specific bolt. It's incredibly fast and power efficient for that one job.
Well, you can't change it.
You can't. It's literally carved into the silicon.
Yeah.
And designing one costs hundreds of millions of dollars. It's a huge gamble.
But for companies running millions of servers, the payoff and power savings and less reliance on NVIDIA, it must be worth it.
Totally worth it. And Google was the first to take that leap with its TPU, the Tensor Processing Unit, way back in 2015.
And that was a huge deal, wasn't it?
Oh, immense. The TPU actually helped lead to the invention of the transformer architecture in 2017. The engine behind ChatGPT and everything else. Yeah, and now they're on their 7th generation, and Anthropic is training its models on up to 1 million of them.
1 million. The source described the TPU like one big factory conveyor belt. What does that mean?
It means it's a very rigid grid, just hyper-optimized for the exact kind of matrix math needed for deep learning. Super fast, but only if the problem fits that structure.
So Amazon Web Services, AWS, they came in next with Trainium. But their approach seems a little different.
It is. Their chip is less like one big conveyor belt and more like a cluster of workshops. It has lots of small, flexible tensor engines.
So it's more versatile.
More versatile, it can handle training and inference really well, which is great for their cloud customers. And they claim it offers, what, 30 to 40% better price performance?
And they've got a big deal with Anthropic, too.
500,000 Trainium2 chips. But you have to remember, these giants aren't doing it all alone. They have back-end partners, and Broadcom is just dominating that space.
Right, they provide the specialized IP and networking that gets built into these custom chips.
They're winning like 70 to 80% of that market. They work with Google, Meta, and they have a future deal with OpenAI starting in 2026 to help them build their own chips. It's a crucial, often invisible layer of this whole race.
Let's take a brief break for a special message from our producer, Curt Robbins.
Hi, this is Curt Robbins. First, thanks for listening. I truly appreciate your support. I want to let you know that I'm currently accepting new clients. My rates are affordable, and I have more than 25 years of experience working for enterprise companies like Microsoft, Northrop Grumman, Oracle, PNC Bank, FedEx, USAA, and Wells Fargo, among many others. If you want to improve your IT documentation and communications, hire me. I deliver fast, know how to use AI to improve efficiency and accuracy, and love going the extra mile to satisfy my clients. Thank you for subscribing and listening. Back to you, Daphne and Fred.
Welcome back to the AI for Career Success podcast.
Okay, so before the break, we were focused on these enormous, power-hungry chips in cloud data centers.
But the game is really shifting now. As the AI models get better, the focus moves to running inference, locally on your own device.
Edge AI. So the AI runs on my laptop or phone, not in some distant cloud.
Exactly. And that's enabled by a new kind of chip, the NPU, or a neural processing unit.
And this isn't a separate graphics card, right?
No, it's a dedicated AI accelerator that's built right into the main chip, the system on a chip in your phone or laptop. Super power efficient.
So why do I, as a professional, care if my laptop has an NPU?
Two huge reasons. First, speed. You get instant responses for things like live transcription. Second, and this is critical for business, privacy. The data never leaves your device.
You maintain control. That's huge.
It's massive. And the players here are the ones you'd expect. Qualcomm, Intel, AMD. And Apple, of course, has been a leader here for years with the neural engine in their M-series chips.
Now, what about that middle ground you mentioned, FPGAs?
Right. Field programmable gate arrays. These are kind of the choice when you need flexibility, but an ASIC is just too expensive or risky.
So they're customizable.
You can actually reprogram them with software after they're made. You lose some raw speed compared to a perfect ASIC, but you gain this incredible adaptability. It's great for prototyping or for niche markets.
Okay, so beyond the design, there's the massive bottleneck of just making the things.
The manufacturing. Yeah, and almost everyone, Nvidia, Google, Amazon, they all rely on one company, TSMC, Taiwan Semiconductor Manufacturing Company.
Which is a huge geopolitical risk.
A massive one. And that's why you're seeing this huge push with things like the CHIPS Act. TSMC is building a giant new fabrication plant in Arizona.
And Intel is getting back in the game.
They're reviving their foundry business, trying to bring that state-of-the-art manufacturing back to the U.S. This is about supply chain security. It's
Right.
not just about who designs the best chip, but who can physically forge it.
But the source mentioned another challenge. A non-chip challenge that might be the biggest one of all.
Energy.
Just getting enough power.
Exactly. These AI data centers need exponential amounts of power. And the source commentary made a really sharp point that the U.S. has a lot of energy risk and infrastructure challenges.
More so than other countries.
More so than China, which has apparently managed that side of its AI build-out much more effectively. So even if we have the best chips, the question is, can we afford to power them?
So that efficiency we talked about with the ASICs, it's not just about saving money on chips. It's about saving energy.
That's the ultimate connection. Every single gain in silicon efficiency, whether it's in the cloud or on your laptop, it directly reduces that energy risk.
So as we wrap up, this whole competition is just incredibly intense. Nvidia still has this huge lead.
They do, and that's largely because of their software ecosystem, CUDA. They spent decades building a moat that developers are locked into.
But the market is just so vast.
It's so vast, and the need for efficiency and control is so high that these custom ASICs are just going to keep accelerating the race.
So what's the takeaway for a professional who's using these tools every day?
I mean, it's that the silicon matters. The chip choice directly dictates the cost, the power, and the ultimate capability of the AI services you depend on.
So your competitive edge really depends on understanding this infrastructure battle that's happening just underneath the surface.
That's it, exactly. Whether you're optimizing for a GPU or choosing a cloud provider based on their custom chips, the silicon is the new differentiator.
Thank you for listening to the AI for Career Success podcast from Curt Robbins, where we help you get smarter than your competition. Remember to like, subscribe, comment, and share. We'll see you next time.